Have you ever wondered how the earth we walk on every day was formed? Our earth is a complex and beautiful planet that has been evolving for billions of years. It's fascinating to think about how it all began. In this video, we will explore the formation of the earth and take a closer look at the processes that led to the creation of our home. Get ready to be amazed by the wonders of our planet as we journey back in time to when it all began. Earth formed about 4.5 billion years ago from a cloud of dust and gas. This cloud collapsed and formed a spinning disk called the protoplanetary disk. Dust particles in the disk collided and stuck together, growing into larger objects. These objects eventually collided to form the planets, including Earth. In the early stages, Earth was hot and experienced intense bombardment from asteroids and comets. Over time, it cooled and developed a solid crust, followed by the formation of the atmosphere and oceans. The Earth's interior is still hot, causing molten rock in the mantle to move, leading to plate tectonics. This process creates mountains, volcanoes, and earthquakes. The Earth is a dynamic planet, continually changing due to erosion, weathering, and plate tectonics. The atmosphere and oceans also undergo changes influenced by the sun, moon, and other factors. Unique in our solar system, Earth supports life. Factors such as its atmosphere, oceans, and climate have played crucial roles in the development of life on our planet. Let's deep understand the formation of Earth. Nebular hypothesis. This is a fascinating concept that helps us understand how our solar system came to be. According to this theory, our Sun and all the planets in our solar system formed from a vast cloud of gas and dust that existed billions of years ago. According to this theory, a long time ago, there was a giant cloud of gas and dust in space called the solar nebula. This cloud collapsed under its own gravity and started spinning. As it spun, the center became very hot and formed a protosun. Around the protosun, there was a rotating disk of gas and dust called the protoplanetary disk. Within this disk, tiny particles stuck together to form bigger objects called planetesimals. These planetesimals then collided and grew into protoplanets. One of these protoplanets eventually became Earth. It grew by gathering more and more material from the protoplanetary disk. As it grew, it also got hotter. The interior of Earth differentiated, with heavy materials sinking to the center and lighter materials rising to the surface. Finally, after millions of years, Earth reached its current size and shape. This process also happened for other planets in the solar system. So, the nebular hypothesis explains that the planets, including Earth, formed from a spinning disk of gas and dust around the young Sun. Disk formation. Disk formation is a simple explanation of how a disk-shaped structure forms in space. As the solar nebula collapsed, it formed a disc-shaped structure with a central concentration of matter known as the protosun at the center. The remaining material in the disk began to clump together due to mutual gravitational attraction. Planetesimal formation. Within the protoplanetary disk, small dust grains collided and stuck together, forming larger objects called planetesimals. Over time, these planetesimals continued to collide and grow, eventually reaching sizes of several kilometers. Protoplanet formation. Through continued collisions and accretion, some planetesimals grew into larger bodies known as protoplanets. Protoplanets were several hundred kilometers in size and began exerting significant gravitational influence on their surroundings. Planetary differentiation. As protoplanets continued to grow, they underwent a process called planetary differentiation. The interior of a protoplanet heated up due to the decay of radioactive isotopes and the energy released by impacts. This caused the differentiation of materials, with heavier elements sinking towards the center and lighter elements rising to the surface. Earth formation. One of the protoplanets in the disk eventually became Earth. It is believed that a Mars-sized object called Theia collided with the young Earth in a cataclysmic event known as the Giant Impact. This collision led to the ejection of material into space and the formation of a debris disk around Earth. Moon formation. The debris disk resulting from the giant impact eventually coalesced to form the Moon. Over time, the Moon's orbit stabilized and it became Earth's natural satellite. Planetary evolution. After its formation, Earth underwent a phase of intense volcanic activity and frequent impacts from asteroids and comets. Gradually, the Earth's surface cooled, allowing for the formation of oceans and the development of early atmosphere through volcanic outgassing. Continents and oceans. Over millions of years, Earth's crust underwent processes such as plate tectonics and volcanic activity, resulting in the formation of continents and oceans as we see them today. Life on Earth. The Earth is the only planet known to support life. Life on Earth is thought to have arisen about 3.8 billion years ago. The first life forms were simple, single-celled organisms. Over time, life evolved to become more complex. Today, the Earth is home to a vast array of life forms, from bacteria to plants to animals. It is important to note that while the scientific community generally agrees on the overall process of Earth's formation, some details and specific mechanisms are still subjects of ongoing research and investigation. For more such informative and interesting content, please subscribe to our channel. Thank you.